Okay, so today we're going to get into acids and bases, and this should be a little bit of review from previous year, but let's just get into it so that we know what we're all on the same page. This is there's really two major types of definitions of acids and bases. Really three, but we're going to talk about two. The one that we don't talk about as much is a Lewis acid and base. But the Arrhenius acid is kind of, Arrhenius acid and base is kind of our standard definition. The one that we use a lot is an acid is something that increases the H plus concentration in water. So that would be your acids are the ones that have an H in front, so something like HCl, hydrochloric acid, H2SO4, sulfuric acid, HC2, H3O2, which is acetic acid. Those would be things that increase the H plus concentration in water. And then a base, an Arrhenius base, is something that increases the OH minus concentration in water. Those would be things that have a hydroxide, the OH is hydroxide, at the end. So something like sodium hydroxide or barium hydroxide or lithium hydroxide, things like that. Okay, so if I put those in water, they're going to dissociate, and I'm going to produce more OH minus, more hydroxide, and therefore increasing the pH. Then the Bronsted-Lowry definition. So Arrhenius was this is kind of like the basic one, but then Bronsted-Lowry came along and said, well, that doesn't include, or that doesn't show all of the different things that we can consider an acid or base. So what Bronsted-Lowry said is that an acid is anything that donates a proton. So in this case, a proton is just an H plus ion, because hydrogen, if you take away an electron, all that's left is the proton. So an acid would be something like NH4 plus, like ammonium. Because what ammonium can do is give away this extra H, and then that would be a proton donor. And a base is something like NH3, right? Because it has an extra, the nitrogen has an extra lone pair, and it can then accept an extra H. Okay? So when we say proton donor, proton acceptor, we mean we're talking about the H's. Okay, H plus. So what we can do then is determine the acid, the base, and then the conjugate acid and the conjugate base with this Bronsted. We're going to specifically in this class focus on this Bronsted-Lowry definition. So if we do take something like NH3 and we add it to water, what's going to happen is NH3 is the proton acceptor. So this H, one of these H's from water, is going to go to the NH3. So NH4 is going to be produced. And then we're going to be left with OH minus. So NH4 plus and then OH minus. Now, so how do we label this? So what happened to NH3? It accepted a proton, so that would be our base. And water, in this case, donated a proton, so that would be considered our acid. So then, what would NH4 be considered? Well, the base turns into the conjugate acid after it gains its proton. So, in this case, NH4 is the conjugate acid. And then when the acid loses its or donates its proton, whatever's left becomes the conjugate base. So in this case, the hydroxide is the conjugate base. And you can think about it like this. Well, NH4 now has an extra proton. So what can it do with its proton? It can actually give it back to OH minus. So it would turn, in that case, it would become an acid. Okay. So what about if we have something like HCl plus H2O, and I should be, these would be in equilibrium, so I should be putting a double-headed arrow here. So what's going to happen here? Well, I already know that this is hydrochloric acid, so it's probably going to give its proton to water. So if we do that, it's going to be H3O plus Cl minus. So this is my acid here. In this case, water acts as a base because it accepts a proton. So now H3O plus would be our conjugate acid because it's what the base turned into after it gained an H. And then Cl minus would be my conjugate base because it's what the acid turned into after it donated a proton. Okay. So that what you should be able to do is identify, given an equation or even just given, if I want to know what is the conjugate base for let's say I have NH2 minus. And what's the conjugate acid? Well, the conjugate acid would be whatever happened after it gained an H. So that would be NH3. So in this case, this would be the base because it accepted a proton. This would be the conjugate acid. Okay. If I have something like, HNO2, and I wanted to know what is its, so this was an acid, what's its conjugate base? Well, I just take the H off. There's its conjugate base. Because now it can accept the proton because it has that minus charge. Okay. So, I hope this helps. Let me know if you have any questions.